This is Alphonse, and this is my presentation on HTTP and HTTPS. Hypertext Transfer Protocol. HTTP is the asymmetric request response client-server protocol. HTTP sends a request message to a HTTP server. What the server will do in return is to send a response message. In other words, it is a pull protocol where the client will pull the information from the server and will disperse and will push down the information to the client. Being that it's a stateless protocol where the current request that it will send, usually the system has no idea what had been requested before. What a stateless protocol will do is to negotiate the data type and to allow the system to build independently onto the data that is being transferred. There are 4 parts on the URL. Part number 1 is the protocol. Protocol is the application level protocol used by the client and the server. For example, of FTP or a telnet or even HTTP. A host name is usually the domain name or the IP address. The port, the TCP port number that the server is what the server is listening to for incoming requests from clients. And the path and the file name, the name, usually the name and the location of the request resource under the server base directory. HTTP protocol. As mentioned, whenever you enter your URL into the address box, the browser would translate your URL into a request message according to the specified protocol. And then it will send the request message to the server. When this request message reaches the server can take 1 or 2 actions, or 1, 2, or 3 actions. The server can take the request and map the request into a file under the server's directory, and it will return the file of the requested information to the client. The server can also either interpret the request received, map the request, and program it into the server. It will then take the program and to return the output of the program to the client. Lastly, but not least, the request might not be able to be satisfied by the server. What the server will do is to return to you an error message. HTTP over TCP IP. HTTP, as I mentioned earlier, it's a client-server application level protocol. What that means, it typically run over a TCP IP connection. HTTP does not need a TCP IP connection. What it does, it will presume this just for transport. Any transport protocol that provides such guarantees can be used by the HTTP client server. A TCP IP, TCP stands for Transmission Control Protocol, and IP, Internet Protocol, is just a set of transport and network layer protocols for machines to communicate with each other. The IP protocol is a network layer protocol, as you know. It deals with network addressing and routing. In an IP network, each machine has an assigned IP address, and the IP software is responsible for routing the messages from the source IP to the destination IP. And the TCP transmission protocol is a transport layer protocol responsible for establishing connections between 2 machines. The TCP will usually consist of 2 protocols, the TCP and the UDP. The UDP stands for User Datagram Package. The TCP is what we refer to as the reliable. Each packet will have a sequence number and acknowledgement that is expected. A packet will be transmitted into, if it's not received by a receiver. The packet delivery is usually guaranteed in the TCP, whereas in the UDP, it does not guarantee packet delivery. Therefore, it's not as reliable as the TCP. However, if there is less network overhead, you can use the UDP for applications such as video or audio streaming, where reliability is really not that critical to the user. Below I have an example of a layer network of how the HTTP operates over the TCP and ICP. HTTPS, Hypertext Transfer Protocol. How the HTTPS actually works. HTTPS has 2 layers. It has the SSL and the TLS layer. the SSL and the TLS are encryption layers on top of the HTTPS. The servers and the clients still speak exactly the same HTTP to each other, but over now a secure SSL connection that will encrypt and decrypt all the requests and the responses. The SSL layer has two main purposes: to verify that you're talking directly to the server that you think you are talking to, it to ensure that only the server can read what you send it, and only you can read what it sends back. The really clever part is that anyone can intercept every single one of the messages you exchange with the server, including the ones you are agreeing on the key and encryption strategies to use. And whoever is intercepting that communication cannot in any way be able to read the actual data on it, which is pretty neat. How an SSL connection is established. An SSL connection is established between the client and the server, usually through what we refer to as a handshake. The goals of this connection is to satisfy the client that is talking to the right server, and the vice versa, that the server is talking to the client. Set up the handshake, and to make sure that the parties have agreed to all the necessary keys and algorithms to communicate together. One of the very important thing to remember is that once the connection has been established, both parties have to agree to what algorithms and the keys they have to use. And the three main phases of establishing this connection is the handshake begins with the client sending a client hello message. What this will do, this will contain all the information the server needs in order to connect to the client server via the SSL net connection. The server then responds to the server hello, which contains very similar information required by the client, including the decision based on the client's preferences. Secondly, there will be a certificate exchange. Now that contact has been established, the server has to prove its identity to the client. This can be achieved using the SSL certificate, which is it's almost like a passport. The SSL certificate contains some various pieces of data, including the name of the owner, the property, which is the domain that it's attached to. And the clients will check and verify that he can trust the certificate authority. And last but not least, there'll be a key exchange. The encryption of the actual message and data exchanged by the client and the server will be done using very similar symmetric algorithms. The client then will generate a random key to be used for the main symmetric algorithm. It will encrypt it, and it will be agreed upon the hello phase and the server public key found on the SSL certificate. Certificates. At the most basic level, we have the trust. The two reasons as to why you might trust a certificate: if it's on the list of certificates that you trust in an implicit manner, if the certificate is able to prove that it is trusted by the controller of one of the certificates on the above list. The first criteria is to check if your browser has pre-installed trusted SSL certificates from a CA that you can view, add, or remove from. These certificates are controlled by a centralized group. In theory, they're supposed to be extremely secure. If a server presents a certificate that lists from a list that's secure, then you can trust them. The second criteria of deciding if you can trust something, it's a little bit much harder. This is where you have to use things such as digital signatures. SSL certificates will have an associated public or private key. The public key is usually distributed as a part of the certificate, and the private key, it has to be very safely guarded and incredibly guarded. A digital signature has to be signed by another authority, whereby the authority will effectively go on record and verify that the certificate can be trusted. The authority will use the same private key and encrypt all the contents of the certificate and pretty much anyone can decrypt this signature using the authority's public key and verify that the results you're getting, they're the expected results. But you can only do it with the private key, which makes it very safe. The best HTTP and HTTPS practices. You need to use robust security certificates. You must obtain, or you should obtain, security certificate as a part of enabling your HTTPS for your site. The certificate, you should make sure that it has been issued to you by a CA, a certificate authority, which takes several steps to verify that the web address you're actually using belongs to your organization. That what this will do, this will protect your customers from any man-in-the-middle attacks. When setting up your certificate, it's good to ensure that you have a high level of security by choosing a 2048-bit key. If you already have a certificate with a weaker key, like a 1024-bit, you can upgrade it to a 2048-bit key. When choosing your certificate, keep in mind the following. You need to get a certificate from a CA who guarantees or offers you technical support. You need to decide the kind of certificate to get. If you want a single certificate for a single secure origin, if you want a wildcard certificate for multiple well-known secure origins, or if you want a multi-domain certificate for multiple well-known secure origins. You can also redirect users and search engines to the HTTPS page or your resource with the server side for your HTTP connections, which is your 301 HTTP server side. You can also use protocols which are relative for all the other domains. Update your sites links to link them directly to your HTTPS. You can also use a web server that supports your HSTS, which stands for Strict Transport Security, and make sure that it's enabled in your system. Which the HSTS tells you, it tells the browser to request pages only using HTTPS. Even if the user was to enter HTTP into their browser location bar, it will automatically request the HTTPS. It also tells Google and other sites to only serve secure URLs into your search results. This minimizes any risk of any unsecured content coming into your network or your system. Some of the common mistakes are things that you need to keep mind of. You need to make sure that you don't have any expired certificates. Make sure that they're always up to date. Make sure that the certificate you have is registered to the correct website. Check that you have registered your certificate with your correct hostname, so that you don't have any mismatch errors. You also need to be aware of any inconsistencies between your HTTP and your HTTPS URLs. Use protocols which are relative to either HTTP or HTTPS. Don't have any embedded HTTPS contents on HTTPS pages. Last but not least, you also need to make sure that the content you have on your HTTP site and your HTTPS is the same. And that would be it for my presentation. Thank you.